Hello and welcome to the Space Madness Podcast. This is your host, Jeff Nosanov, and I think we're up to episode 43. And today we are talking about shooting things into space with a giant gun with our guest, Mike Grace. And, there's really not much more to say than that when that is the subject matter. So, Mike, why don't you introduce yourself and tell us what you're doing, and then we'll see how you got there.
Oh, cool. My name's, as said, Mike Grace. I'm the CEO of Longshot. Longshot's a kinetic launch company based in the Bay Area, San Francisco, and we've been going at it for about 4 years. I have a multi-injection gun in Oakland right now. That's our old location. We still have it for a few more months. That's about 75 feet long, that we fired probably about 120, 130 times up to speeds between Mach 4, Mach 5. I could probably goose it up to like Mach 6 or Mach 7, but I'd have to take it out to the desert, fill it with hydrogen. That's how you'd get the speed out of that system. But that's kind of like I would call that like our 6-inch interior diameter, 75 foot long. That's like our benchtop prototype scale system. And then now I have the largest gun in the world here in Alameda that is about 30-inch interior diameter and 120 long. So I can put you on a skateboard and send you down that thing nice and easy. That's kind of like that is a short prototype, but a full diameter prototype for a system we have planned for the middle of the desert, very likely Nevada, could potentially be doing one in New Mexico as well. That would be throwing 100 kilograms to release at speeds between Mach 5 and Mach 7. It's literally just a physically scaled up version of what we built in Oakland. So then there's kind of like a crawl, walk, run approach here. Start with that. Do a bunch of like hypersonics type business, and then Mach 10, Mach 15, and then you're pushing up towards Mach 20, Mach 25 orbital velocities.
That is awesome. Lots of questions come to mind.
Please,
and I usually go back to the beginning, but I want to ask the question before I lose it, which is, at that point, what is the definition of a gun anymore when it is 100 feet long?
I really call it a gun because it's evocative. It gets the idea across, but it's not actually accelerating vehicles using the exact same mechanism. Like we do use kind of like pressurized expanding gas.
Okay.
Ours is a gas accelerator. Gun kind of works, but a normal gun goes boom. My gun goes ba 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 ba. Many volts.
Okay.
The maximum pressure, the maximum temperature, and the maximum G-force is applied to the vehicle cut in half. So if you build something that is very long, all of a sudden the materials are very cheap. Like you reach a threshold where you're kind of like below like 3,000 PSI peak in the entire system. And that means that everything's made out of mild steel and concrete and sand. There's no Inconel. There's no custom pipe. It's all just like spiral welded or straight seamed, like large diameter tubing from like the... You're basically all of a sudden building an aerospace company out of civil engineering, right? And like that is a very different cost basis. So the core trade-off here is that we realized that, if you're thinking about your whole project from like the total cost of CapEx and non-recurring engineering and everything, it's not just the total energy you invest, it's actually the peak energy that the system experiences is a huge governor of that cost. If your system experiences 90,000 PSI for a tiny fraction of a second, you have to design around that fraction of a second.
Right.
So our system, like peak pressure it's like room temperature, and the peak pressure is around like less than you'd see in a scuba tank. And what you do is you consume a huge amount of land, but like land in the middle of the desert is quite cheap.
So basically, you spread out the single impulse to many smaller impulses over a distance, and there your maximum peak pressure is much lower, and you're not requiring unobtainium anymore.
Correct. For a given energy investment, you stretch it out. And the thing is, if you open up your browser and you look for a German superweapon from World War II called the V3, you will see that this is not a new idea, that the Germans had a multi-injection gun in World War II that bombarded Luxembourg as a prototype.
Okay.
And it's the same thing. Like the Germans, this is late in the war. This is like 43, 44. So they had lost the ability to basically manufacture proper gun tube at that point. So they had to find technologies that would let them have a long range, high speed effect that you could build out a fucking sewer pipe, which is what they did. So it's the same idea of you're being much gentler to the gun.
Sure.
Now, I know that many people might be listening to this, but I'm holding in my hands right now a book.
Cool.
Gerald Bull, actually, who is a luminary of this field. But it's a
Uh,
history of German superguns from World War One, and then Project Heart from 1960s. And these guns were only good for about 60 shots before they had to literally recondition the barrels. So the
okay.
Germans were in World War II. They were like, okay, that was a bad idea. How do we make something that's like deeply reusable so we can blow London up?
Yeah,
Anyway, they got too busy losing the war to
sure.
get that done. But it's actually an old idea. Like most great ideas in aerospace engineering, your goal is to identify a technology some German dude worked on in the 1930s and then steal it.
Fair enough. I think around that time of the war, they also ran out, the amphetamine factories were running out, so they
Yes,
couldn't keep
I
up.
know.
They
Then
couldn't keep up
everybody's
the
going through
pace.
withdrawals.
Yeah.
Ooh.
Wow. Okay. That might be one of my favorite introductions so far. So tell me, what was the series of events in your life that led you to building a giant space gun?
I am an economist by training. I have a bachelor's degree in economics. I have a master's degree in molecular biology.
Uh,
Um, I've always cared about space, but I knew I never quite had the math chops to be an aerospace engineer. So I decided
okay.
to do kind of the next mathiest thing I found interesting, which was economics. But like I'd gone to like a bunch of Mars Society meetings as a
Hmm.
kid, and like I just super into space, man. And so in my undergraduate, I was at a community college, and I took a I knew I was getting a degree in economics, but I had to do a science course as a requirement for my associate's degree. And I asked my professor if I could do an extra credit project on using engineered microorganisms to terraform Mars. And she said,
Okay.
like, bro, I'm not going to stop you. Like, knock yourself.
Yeah.
And I ended up turning that into a 10-minute YouTube video because 10 minutes was as long as YouTube videos could be at the time, right?
Okay.
Because it was like, it felt really bad putting a lot of love into that project. And then, at the end of the semester, you put it in the garbage can and you never see it again. So
Sure.
I made a YouTube video out of it. And then a guy working at NASA Ames Research Center in an astrobiology lab
Uh-huh.
saw it and was like, that's dope. You should come work for me for no money for a summer. And I said, of course, of course. So I got in my car. I drove from North Carolina to the Bay Area and I never went back. I ended up moving into a co-op because like it's incredibly expensive to live. I was
Hmm.
working literally the cool thing about working for NASA is they can pay you minimum wage. And when I say minimum wage, I mean federal minimum wage. So I'm living in the
Yeah.
Bay Area working for 7.20 an hour, cleaning beakers and doing PCRs all day long inside
Mm.
this like laboratory for this astrobiology guy who was getting his PhD. I moved into a house in Cupertino with like 8 other people, actually more like 13 other people. It was started by a bunch of people who were working at the center, NASA Ames.
Okay.
And it was actually the house where Planet Labs started.
Wow.
We were like building satellites in the garage. That was actually my introduction to startups. So I'm
Cool.
like living in a bunk bed, sleeping on a bunk bed upstairs in a room with like 4 other guys. And then
Mm.
in the garage, there's these people trying to start an Earth observation company in like 2012, 2013.
Mm.
Um, so I want to say that's kind of like my life took a hard pivot, right? In that, like, I'm
Hmm.
studying economics in North Carolina, and then all of a sudden, I'm working at NASA Ames Research Center as a mere technician, but like, I'm surrounded in this kind of milieu of people who are doing like space biosciences
Mm.
and startups, and that was a huge shift in like the trajectory of my life. I had been in the army before that. I went to
Okay.
Afghanistan a couple times. I was a paratrooper, fucking getting shot
Mm.
at in Afghanistan. Hate it. I'm delicate, baby. I don't like it. This is a body made for loving, not for fighting. Don't like shooting at people. Don't like getting shot at. But yeah, so then I ended up staying in California until I got residency, living in that co-op. I moved in full time, and then I was working at NASA Ames while finishing my bachelor's degree at Santa Cruz.
Hmm.
Go Banana Slugs, best mascot ever.
Absolutely. Yeah.
Yeah, then I finished that. I ended up working at a few startups and kind of like biotech and aerospace. I worked at Deep Space
Hmm.
Industries, which was an asteroid
Okay.
mining company that was an absolute catastrophe. But like,
Okay.
like I will say, Dan Faber, who was the CEO of it, sort of at the end, was a fucking mensch. Like he's an awesome dude, but like the company was structurally fucked from the get go. It was just
I
working
see.
for like a really bad startup is like an awesome way to learn. It's a great education.
I think there's a parallel with the older experience of having a really bad manager for a while
Oh,
and
totally.
learning about that. Because usually at those larger organizations, you don't have the visibility into the structural issues. You just know your something doesn't make sense.
Yeah, yeah, yeah.
Wow.
So I want to say like that whole pipeline kind of led me up
Mm,
to I was working at a startup, it fell apart. I went back to school. I got a master's in molecular biology, which is where
mm,
most of my work experience was at that point. And then I finished up my master's. And then I'm like, okay, I'm like 35 now. If I'm going to start my own startup, I need to go,
mm.
right? It's like having an infant. You don't want to do it for your first time in your 40s. You want to still have a little bit of that pep in your step,
Yes.
right?
Yes.
So I asked my wife for like a 6 month leave of absence of like, can I like not earn money for 6 months and like try this? And she had already
Yeah.
supported me through the master's degree. So this was a very
Sure.
patient woman.
Yes.
And she said yes. And I spent that entire 6 months raising like $25,000 in friends and family's money for Longshot. Then I built a Mach 1.8 potato gun out of PVC in like my
Hmm.
backyard with some friends' help, multi-injection potato gun.
Okay.
And that was sufficient to like convince the Air Force, like, okay, we'll give you a phase 2 SBIR. And
Wow.
once I got that, I was able to raise money from VCs. This
Sure.
was in like right at the beginning of COVID, actually, like a bad time to start,
Okay.
actually. But yeah,
Yeah.
that was it.
So first what you're saying is your wife gave you a lot of grace.
And I will say she is a
Sorry,
civil
that was a
engineer.
joke. That was a terrible joke. Okay.
I give her a lot of grace. She gives me a lot of grace. Yeah,
Okay.
she probably did. And I want to say, Diana, my wife is at NASA Ames Research Center. We met there, and she became a
Cool.
civil servant. I went off into startup land. But she
Okay.
builds instrumentation for life detection missions to Venus, Mars.
I
It's awesome.
I wonder if I've overlapped with her.
Where did you work?
Well, I was a JPL, but I've been a contractor for proposals for life detection in several different places. Yeah.
She did. She was big on BioSentinel. That went
Uh,
up on the first SLS launch.
okay.
She's been working for a few years on a Venus atmospheric probe that would basically do a
Okay.
bunch of bioaerosol
Cool.
spectroscopy while it was falling, that sort of thing.
Looking for bugs in the jet stream up there.
Yeah, she's a skeptic. I think that
Okay.
there are a bunch of people who study like atmospheric life in Venus who are like, yeah, it's totally going to be a thing, and she's like,
Yeah. Okay. Well, let's see. So
oh,
you wanna?
finally, I want to say
Yeah.
this has been an incredibly stupid, long way of answering your question.
Not
I
at all.
knew that unit economics of putting stuff into space is like the thing. It's the
Yes.
thing this entire fucking industry is built around. The thing.
Yes.
And if you're not attacking that, you're not
Mhm.
actually doing anything interesting. Like, this is my incredibly
Sure.
shopaholic way of like approaching
Sure.
this. I
Well,
had to
it's
attack that.
and if that unit is a potato, so much the better. My comment was going to be that you may be the only person to win a phase 2 with a potato gun.
Well, I mean, hey, man, you get PVC up to Mach 1.8. I want to say that's pretty impressive.
Really?
PVC does not want to go to those speeds. That thing was, I mean, again, we have like a hypersonic multi-injection gun, everything down here that's like huge. That gun in my garage was by far the most dangerous thing I've ever worked on. That thing wanted to explode every time we shot it.
So I really like this. So this is like right up my alley in terms of the way you raise capital. Small amounts of money and then a government grant, basically, and then VCs. It's a great model.
I also want to say, like, VCs, particularly for hardware dense plays, don't want to go it alone. They want to see a certain amount of government buy-in, and that is a prerequisite, And I will say, I tried to pitch Longshot as a pure space play for like the first 3 or 4 months, and I got my fucking teeth kicked in, right? Because like there's been a narrative shift over the years, right? Like when SpaceX landed the first stage of the Falcon 9, a bunch of dipshits rushed into investing in rocket companies that looked like SpaceX, right? And they lost their fucking shirts because it turns out that rockets are a natural monopoly. The person who builds the first big rocket aggregates demand into themselves, and then everybody else is fucked. Somebody would need to give Peter Beck $25 billion for him to have a shot at being competitive with Starship. The money doesn't exist. And everybody kind of realized that. And then sort of like by like 2015, 2016, it became impossible to raise money. Well, harder and harder and harder to raise money for kind of like launch plays. I think that's changing now. I think the SpaceX IPO is going to like really change the story out there. But we have to shift to hypersonics and much more defense-oriented work in the near term.
Well, it's remarkable coincidence. My guest for an episode I recorded yesterday, we're talking about hypersonic passenger travel as what's that? As one of them, yeah. But just as a concept, how do we break why did the subsonic passenger travel model stick around for 60 years and how does it get broken? How do we get places, an order of magnitude faster?
You want to know my real answer to that one?
Sure.
World War II. It's World War II.
Sure.
Like, we basically locked aerospace technology into amber at the conclusion of World War II. World War II was an incredible, like, engine of change. And then we basically said, okay, this is the technology basis that we're going to go forward on.
Yeah.
And I think that it is just like historical and technological momentum left over from World War II basically still defines the way flight works today.
I think you're right. And a certain industrial capacity emerged that was developed during World War II that then was the foundation for those businesses that really probably don't want to change too much too fast about what they're doing. Yeah.
And the regulators.
I'm so glad this is going to go out the week after yesterday's episode. So it's really two different looks at the same problem of high-speed transportation of things. So this is great timing. So technical question and then a business question. So I imagine it was a light bulb moment when you decided, oh, what if we spread out the impulse of firing a shot throughout the barrel? So I can imagine a garage idea where you have compressed air kind of inlets into this tube along the length of it, and somehow you chain them and you just see what happens. I mean, is that basically what we're talking about? Okay. And then with the metal version, I imagine you have a digital control of some kind, and you've figured out the timing. And
the hard part is the timing. The technology that makes the whole thing work. Because if you think about it, like, you can have valves that are very, very small and very, very fast, or you can have valves that are very, very big and very slow. But like, unless you have a literal piece of C4 driving your valve and it's one-time use, like, you can't have a large, fast valve. So that was actually like the problem we solved in like the first 2 years. We use burst discs, by the way. So they're basically just disposable. So like what I tell people is the technology under the hood is the extremely precise popping of balloons. My balloons just happen to be made of stainless steel.
Okay. So at first I was thinking you have a compressed gas system that lets in the gas through these valves every X milliseconds, but you're saying it's a little more explosive than that. Microseconds. Yeah, okay.
You need to go microseconds on this one.
Wow.
Tens plus or minus tens of microseconds is what you're looking for.
And that must be at the scale of the operation of the valves themselves. So
yes, if you want to do another thing about like scale that you should understand is that you can't do a kinetic launch system small. It doesn't work.
Sure.
Ballistic coefficient is the only thing that allows you to escape the lower layers of the atmosphere at orbital velocities. So your vehicles must be fucking massive, because as you get more massive, the amount of embodied energy you have to penetrate the atmosphere is going up with the cube, while as your friction and heating is going up with surface area, the square. So like, go big or go home. So eventually you realize you have to have orifices where you're injecting this gas, where you're talking about something that might be multiple meters across. So good luck finding a valve, right?
So your scaling law is mass versus surface area. So your mass has to dominate. Yeah. So, okay. So what was it? You must have had a moment where you were like, this can actually work as long as we can actually scale this up. So can you tell me about that? Was it the potato or was it something post-potato?
It was pre-potato. It was before I built anything. I realized this architecture made a huge amount of sense. But there were kind of two core revelations with this. The first is stretch the energy investment out over the length of the barrel, right? Consistent energy investment. And there are several different technologies that kind of do this. There's a ram accelerator, which is like a floating ramjet inside of a tube. So you just have like the central diamond body of it accelerating into fuel, and then the combustion behind it is driving it forward. Those exist. Hypersciences is a company that's working on commercializing those. But they have kind of like similar problems that ramjets have, which is that they work within certain regimes of fuel richness and speed, right? So they're not kind of like it's hard to generalize across from like standstill to orbital velocities. But they can work. They totally work. There's a guy at the University of Washington. So first thing is like, okay, that's a really important revelation. And that like, if you make the thing longer, you reach a threshold where it becomes a civil engineering project instead of an aerospace engineering project. And that's like core. That is absolutely central. Right? The aerospace
so you're not blowing the gun. So you're not blowing the gun into the previous zip code backwards.
Correct. But also think about the fucking supply chain. The aerospace supply chain is completely fucked for the same reason. How do you feel about bad words on your podcast?
Too late. It's fine.
Yeah,
Yeah.
the aerospace supply chain is completely fucked for the same reason that the pharmaceutical supply chain is completely fucked. The largest
Uh,
purchaser by far is the U.S. government. So people price to fuck the U.S. government. And if you're a third
yes.
party startup or something trying to buy fucking reaction wheels, you're
Yeah.
just gonna get hammered, right? So by being able to get out of the aerospace supply chain, and like SpaceX does this through harsh vertical integration, right? They
Yeah.
completely
Yeah.
vertically integrate, cut out all the suppliers, right? That's how they keep their costs down, and that why they are able to
Well,
sell it's for an order of magnitude lower than like United Launch Alliance.
I don't want to interrupt you, but that does flow right back to the locking of the model at the end of World War II. Also,
Yes, it does. It does.
go on.
And the other thing, and I think that that's for political reasons as well,
Sure.
like trying to split up your manufacturing, decentralize your
Mm,
manufacturing, allows you to put your manufacturing into more congressional districts, and that makes it whatever
yeah.
program it is you're doing more politically stable.
Sure.
So, to some degree, we decided to effectively make defense procurement like a jobs program in this country. And the further away you get from an
Mm,
actual war, like the more that happens. That's the only way you
yeah.
keep like large investments in defense going is by turning them into pork. And that's why the Navy can't build fucking boats anymore. It's ground to a halt over time. It's fundamentally a political inertia problem. So the first thing is build the thing fucking huge and stretch the energy out. The other thing is build it flat on the ground. This is also a cost issue. Like you have a choice. You can elevate something at 45 degrees, or you can build something 25 kilometers long. You can't do both, right? And if you're looking at trying to take like orbital energies, right, and invest that gradually enough that you're being gentle to a satellite, you need a runway to do that. So then the challenge is, okay, well, how do I go up? Our solution to this is don't point the gun up, point the vehicle up. So the vehicle is actually a hypersonic wave rider
What
pipeline.
sounds like an internal runway or a runway inside a tube. It sounded like you were saying you're going to launch something to orbital velocity from a horizontal
Horizontal. Correct.
platform and
Yep.
go through all of the atmosphere to
No,
get
no,
to.
no. So here's the idea. The
Okay.
vehicle is traveling down the tube, but it's actually mounted inside of the accelerator with an angle of attack.
Okay. That makes more sense to me. Yes.
So the vehicle comes out, it hits the atmosphere, and you ramp off of the atmosphere as rapidly as you
Okay.
can. So you trade some of that momentum you've just built up for altitude.
For lift. Okay.
Because, like,
Okay.
if you want to elevate the gun at 45 degrees angle, the maximum practical length you can build something might be 2 kilometers, might be. And it would be
Okay.
extraordinarily expensive.
Yeah. And
You're
it would
looking at
vibrate itself apart, probably.
correct. It would have, like, you'd have to bury half of it, and then you'd build one of the tallest structures in the world on the other side of it. And,
Yeah.
your maximum G load, right, would still be really fucking high. You'd be looking at a maximum G load that's on the order of like, less than 10,000, but probably on the order of like 5,000, 4,000, something like that. That's a lot. That's a heavy
Yeah.
deload. So by building the thing flat on the ground, you can build it to, if you're out in the middle of Western Australia, 25 kilometers is not a long run. So you build this thing flat on the ground, 10 kilometers long, and you can get orbital velocities down to a peak G load of something on the order of like 500 Gs. Your phone is designed to tolerate about 900. And then you go to like
Wow.
every time you double the length of it, you cut that maximum G
Yeah.
in half, and you make the gun like a lot more effective. Also, length has just got like huge advantages to it. So again, the choice to build it flat on the ground actually kind of just unlocks an enormous amount
So
of low cost power you can add to this system with relatively cheap materials.
so when you say orbital velocity with G load 500, is that after you lose energy with the lifting body out the other end of
So
it?
that's just the accelerational G forces that it's
Okay.
experiencing over that length. I mean, if you think about it, like
Okay.
a Falcon 9 is accelerating at 9 Gs over the course
Mm-hmm.
of like 400, 500 kilometers or something like that.
Mm-hmm.
Probably much longer than that, actually, right? It's burning for like 4 or 5
10
minutes.
minutes. Okay.
Yeah,
Yeah.
10 minutes, right? So like, it's building that velocity up over 10 minutes. We're talking about
Sure.
adding the same velocity in about 2 seconds, 2.5 seconds.
2 seconds to go 25 kilometers?
Oh yeah, hypersonic, baby.
Wow.
And that's
Oh,
when
yeah, of course.
it's still accelerating up to orbital
Yeah.
velocity. But look at how fast
Wow.
the ISS goes overhead, right?
Sure. Sure.
That's orbital velocity right there. It's going really quick.
Well, I really like how this really challenges kind of the imagination of flying objects in general. I mean, we're used to aircraft kind of leisurely passing overhead, and we imagine or occasionally see rockets, which we don't see from the same angle the whole time. So there's an illusion of speed,
Correct.
but there's something about a barrel of a rifle, basically.
This would look.
So it's sort of like a rifle, but instead of the rifling, you've got injectors. Or do you also have rifling?
Also, I want to say there's no spin stabilization here. There are actually rails inside of the tube that the vehicle is mounted to. In some ways,
the
tube is really there to keep the atmosphere out more than it is to do anything else. Like, you need to be evacuated inside of the tube, right?
It is vacuum. Okay.
Yeah, you can't accelerate at these speeds inside of it. If you were, you would be like a piston compressing the atmosphere of you otherwise. So
yeah, that was going to be one of my questions, was if it wasn't a vacuum, then once you get to the end of it, there's a huge pressure equalization event that would blow a crater in the ground. So makes more.
You're passing out of a membrane at the end that's holding the atmosphere out, and then you're in the atmosphere. The amount of deceleration you experience from friction with the atmosphere is inversely proportional to mass. The asteroid, I tell people, look, the asteroid that killed the dinosaurs did not meaningfully decelerate upon impacting the Earth, right? Because it was massive. It was massive.
Yeah.
So we're talking about throwing like 10-ton, 20-ton vehicles. I think an MVP, the smallest thing you might want to throw would be like 2 tons, kind of like total wet mass out of this.
Wow.
Yeah. Go bigger.
Okay. So I imagine you get asked often to compare the unit economics to kilograms to orbit per dollar. So what does that end up looking like, in your projections now, if you're comfortable sharing it?
Absolutely. 100%. Well, here, I want to frame it for you like this.
Please.
If you're a rocket scientist, and Jeff, you built a sounding rocket that could take 40 kilograms to 40 kilometers altitude, and you literally soloed this motherfucker. You programmed the avionics, it's liquid fueled, you built the turbopumps, you cut the aluminum, you weld the whole thing together. Right? You build this thing. That's like a powerful missile system. And from the first time you try to launch it, it flies successfully 499 out of 500 times. Jeff, you're the fucking GOAT. You're the best rocket scientist to have ever lived. Right? It normally takes teams of people years and years and years to do that. And they're usually using like legacy motors or legacy avionics or whatever.
And failing 9 times out of the first 10.
And failing 10 times before they get to something reasonable. Now, alternatively, Jeff, if you were a ballistics engineer and you built a gun that could take 40 kilograms to 40 kilometers altitude, but once out of every 500 times somebody pulled on the cord, the fucking thing exploded, you'd be a comical fucking incompetent. The thing is, it's like the difference between building a 747 that can hold 800 people and a building that can hold 800 people. The reason rockets are hard is because they fly. That is a tool for lifting fuel, and it must fly. So kinetic launch has always been a way better way of moving stuff to super high speeds. That's why, like, we use guns, just generally.
Well, there's a interesting historical tangent here on the history of the firearm and the immediate, other than what I understand is some battles in France where the archers won for the first few years. But as soon as the gun got pretty well advanced, everyone on Earth wanted one. I mean, it's not subtle. Yeah.
I would say this, like, I think that, like, I should be able to, my MVP that I have in mind, my version of the Falcon 1 starts at around $300 a kilogram. My version of Starship, like the big version of what I build, goes to below $10 a kilogram. Like, that's where I want to go. I will never fly a human being. Right? My G-forces are always going to be too high. Even the largest version of what I would build, I'm still around 150, 200 Gs. For the record, like, your phone can take like 900. Like, so like satellites are going to be just fine inside of this. But like you and me, not so much.
Well, it does give a new meaning to the shake and bake protocol of testing a satellite before launch if it's going to go in your tube.
Yeah, but I would also say this, like, at those prices, at that price, add some steel gussets. Make your satellite out of steel instead of aluminum. Like, mass is free at that point. You have a lot of options for reinforcing your satellite. You think about designing spacecraft very differently.
That is true. Yeah. Interesting.
Yeah. So, but here's another thing also. Like, if you're Jeff Bezos and you're currently buying fucking rockets from Elon Musk, do you feel good about that? I bet you feel bad. I bet you're
Yeah.
grinding your teeth every night thinking about like
Yeah.
subsidizing your direct competitor as you try to launch a competing satellite. Like
Right.
that's bad.
Well, I was at Amazon Web Services 5 years ago when some of those discussions were going on, and I recall bewilderment that there is so much demand for launch that all of the launchers are saturated for years.
Yes.
So
Yep. And Blue Origin sucks so bad, Jeff Bezos doesn't have enough money to pay them to stop sucking. Like they are so far behind. My opinion on it, like,
really,
yes, my opinion. Like, look, they're celebrating. They're doing victory laps over
mm,
landing a first stage, and they should. That's really hard. But that is literally them catching up to where SpaceX was 14 years ago. They are so fucking far behind. Like, there is
mm,
no path forward for them that doesn't involve tens of billions of dollars of direct subsidy from Jeff Bezos. And I think that subsidy has literally given them brain damage. That is a company that is older than SpaceX,
yeah,
that started 5 years before SpaceX started and is now 15 years behind where SpaceX is today. And it's like, good night, Irene. I'm mad. That's the voice of anger right there. I was used to be a big Blue supporter, but like,
sure,
how many decades need to go by before we just decide this is an abortion here? I think that the rocket market is cooked. Like Elon has won at rockets. Everybody who has a rocket that is trying to compete with Elon Musk has brought like I think that like I was actually doing an interview with Ashley Vance a little while ago, and he's like,
mm,
well, what you're working on is kind of crazy, right? And I'm like, well, yeah, but like, what's also crazy? Trying to do what Elon Musk did like literally 15 years ago and thinking that you're going to compete. That's fucking
yeah,
crazy.
yeah,
Yeah. So by the time Blue has like New Shepard, like has a functional rocket that can theoretically start to compete in the market with Falcon 9, like SpaceX will have been operating Starship for 2 or 3 years. You're born dead, right? You're just cooked.
Well, I think the gamble is that the federal government will support a competitive marketplace out
That
of
is the
almost
only
out of
that is the only reason why Rocket Lab still makes rockets today. Rocket Lab would have exited the market for rockets and focused exclusively on in-space assets had it not been for
okay,
the Air Force begging them to stay in the market and saying, we'll subsidize you. We'll keep buying rockets from you if you stay in the market. And they sell
yeah,
their fucking rockets for $25,000 a kilogram. So they're a fucking irrelevancy from the commercial
yeah,
market. If you're actually interested in launching large constellations, forget about them, right? Forget it. There's one player. The only competitor to SpaceX on the rocket side in the world today, in my opinion, is the PRC. That's it. Because the Chinese
mm,
have enough money. The United States government is like, we would really like there not to be an explicit monopoly here. So we'll like
yeah,
throw something to like, we'll keep the Electron running. We'll throw enough
mm,
business to these other rocket competitors to keep them alive. But they're fucking zombies. And they have like, 1% market share or something.
yeah,
But the PRC has a strategic incentive and like billions of dollars to potentially subsidize iSpace or something like that into competitiveness. So they might.
yeah. I would love to get more experts on China on this podcast. That
You
would
should.
be really. I'm working on it. I
Yeah,
mean,
I think that's
it's
a great idea because I do think that like they're in terms of like competing with
yeah,
Elon for space access via rocket, they're it. I think that if
right.
you want to actually compete with SpaceX,
Mm,
you need a long shot, baby. That's
I love
yeah, you
it.
need a long shot.
Yeah,
You need something like a fundamentally different technical paradigm, or you're
sure.
bringing a knife to a knife fight when the other guy has a fucking sword.
Yeah. Well, so in science fiction and even a lot of old NASA work, they talk about using a railgun. So I'm curious. People must have brought this comparison to you before. Why not use electromagnetism instead of gas?
Why didn't the
Just cu-
Germans try to flatten London with a gigantic magnetic rail accelerator? It turns out that like the
mm,
electrical infrastructure is really fucking hard,
mm.
really hard.
Harder than the civil engineering, basically that you're talking about.
Storing
Okay.
3,000 psi gas is like
Yeah.
trivial.
Yeah.
We do it all the time.
Interesting.
We're versus
Yeah.
like supercapacitors. And if you're looking at like you
Yeah.
have to cryogenically cool your magnets. Like
Yeah.
the Navy and BAE. And again, I'm an economist, so I kind of come to
Mm,
this from like I literally didn't even attack the first principles engineering. I think that the physics of railguns are elegant and simple and beautiful,
mm,
and that's why it's a fucking nerd trap because when you actually get into the engineering of it, it's
mm,
brutal, right? The
mm,
switching, the cooling, the magnets, They're not trivial at all. Like the Navy and BAE spent 15 years and $2 billion trying to build a railgun for the Navy, and they had free nuclear reactors laying around. And the fucking thing sucks. It blows itself apart every single time it shoots, right? They got up to like 1 kilogram to Mach 5, which for the record is what I've done in Oakland. The total bill of materials for the gun that I have in Oakland, it can do like 0.5 kilogram, like Mach 4.5. And like I could take it out to the desert and goose it up to like Mach 6 or so. I'm comfortable saying that is the gas-driven equivalent of the BAE railgun. Like the bill of materials for that gun is $40K. I would sell you that gun with a smile on my face for $100,000. For $100,000.
And I put it in my front yard with a smile on my face.
Totally. Oh, it'd be great. Yeah, keep all your neighbors on their best fucking behavior. But like Navy and BAE, the bill of materials for that thing must have been in the order of like, $100 million. And like the capacitor, switching infrastructure, they're fucking expensive. So like if you think about it, the supply chain they have to dip into to build large, powerful railguns is like nuclear power fission infrastructure. That's that supply chain. Whereas I'm literally buying plumbing infrastructure, right? I am buying, So it's a nerd trap. It's a nerd trap. That's magnetic rail.
Well,
if the Nazis
another word,
did it in the 1940s, we can do it today.
Sure. Another word, of course, being it's over-engineering.
Yes. But again, here's another thing I'll talk to you about. Like, among deep tech investment and like startup, like investors are always going to ask you, like, why are you uniquely suited to do this, and why has nobody done this before, and why can nobody copy you? And that's actually a dumb fucking question that comes from software brain. Because the real reason a deep tech thing can't be copied is because it's hard to do anything in the real world made out of atoms. That's what. Like, SpaceX has 0 patents. The Chinese are just now catching up. Jeff Bezos is just now catching up with where SpaceX was 15 years ago, right? It's just hard to do stuff, right? But like software investors ask that question, and so startup founders want to be able to say, nobody's ever done this before. This project is packed full of technical novelty. There's a fetishization of novelty that's actually an enormous trap, because you can do something that's really hard, or you can do something that is packed full of novelty, but you cannot do both. You'll just lose.
Well, I had a startup company about 10 years ago, and the first time I wrote a check to get a PCB manufactured, I realized, I'd really rather just hit the compile button to test this.
Yeah. Hardware is hard. Hardware is hard. And I think that there's a whole bunch of people. There is a slaughter going on right now out my window in San Francisco, as all these motherfuckers who've been making easy money doing SaaS for the past like 15 years are getting, Anthropic is going to fucking plow them into the ground. And I got to say, I'm fucking laughing. It's a delight to me. Those people have been doing startups on easy mode this whole time. And it turns out the only way you can build a defensible, real business that generates like earth-changing amounts of value is with hardware. You need hardware. You have to have an element of hardware. Software can be there too, but you've got to have hardware. Because software might have eaten the world, but like now software is eating software.
Yes. Yeah. Well, that's another. I was going to say the same thing a different way, that now that the barrier to creating software has never been lower and is dropping, it is still hard to make atoms do what you want them to do.
Correct. And that'll probably remain true for another 20 or 30 years. I give it something like that.
Sure. Well, yeah, I could speculate on how long it will be until you have a plain text prompt that will build something physical for you. That would be interesting.
Elon are betting on that with Optimus, right? He wants to build robots. Robots are how you turn software into like physical action in the world, right? So that's kind of what he's going on. I have no strong opinions one way or the other on Optimus. I have lots of strong opinions on like SpaceX and like instant compute and stuff along those lines.
Well, I have a very, very, I think, modest demand for the first household robots. I just want something to fold my laundry. And then we can go from there.
I want to have like a humanoid robot and like take it to a grocery store and then like yell at it and abuse it, and just to make everybody super uncomfortable. And then I want to program it to cringe when I go lined up like this. Oh, stupid robot! Well, it's like, no, master, please don't hit me anymore.
I am sure
that's what I want to do. That's what I want.
I'm sure that will be a thriving TikTok and YouTube genre as soon as it's available.
I think like humans naturally empathize, and like you're going to put like 4 arms, you're going to put like 2 arms and 2 legs and a head on something, and I just think that like it's so clear. The analogies to slavery are too strong. They're too strong. It's just there's going to be a very interesting transition as human beings actually start interacting with machines that can speak for themselves. Boy, we are not
Hmm.
prepared for that. We are not prepared for that.
Well, we can barely handle each other or even ourselves and our own voices. So, as much as I enjoy tangents, I want to get back to the actual milestones you've achieved with the launch system. So
Like high
what is
supersonic,
the
high supersonic, like low hypersonic at this point. I
okay?
hope to, in a year, have a half-kilometer long 90 centimeter, that's the 30-inch system,
Hmm.
system deployed out in Nevada that's throwing 100 kilograms to free flight
Hmm.
at like Mach 5 and then lower masses to higher speeds.
So then, how far does that actually travel once it's left the
Not
system?
there will literally be an earth berm. It'll fly for a little while and hit the earth berm, and that's it.
Okay, so
I'm gonna
you're
say,
not okay.
yeah, that's strictly for sort of like testing heat shields,
Sure.
scramjets, ramjets,
Okay.
supersonic aerodynamics, aerothermodynamics, things like that.
Yeah.
If you want to do like up and out of the atmosphere, like I think the minimum entry point for that is closer to like 3 kilometers per second, like Mach 15, Mach 12, something like that. You can get
Well,
up and out of the atmosphere at those speeds.
I'm thinking more just in terms of flight to some distant point, 10 miles away, 100 miles away.
You could probably do that. You could do that with Mach 5, but
Okay.
I'm not terribly interested in it, I'll admit. I think that there are probably like weapons and military system applications there, but like I think that for the near term, hypersonic test and technology development is a great starting place for this.
Hmm.
And as kind of a weapon system, it has some disadvantages in that you can't hide it. Like, oh, here's another thing.
Yeah.
Why did this technology get buried after World War II? Why do we put stuff into space with rockets? Answer for you, Jeff. Great question, Jeff. Great question. If you're
Because
trying to deliver a hydrogen bomb to the other side of the planet Earth, do you give a fuck about marginal cost? You do not. But you
right.
do care about the ability to put your delivery system onto a submarine or to a
Yeah.
train or to a truck or
Yeah.
an airplane. And you will never do that with a super gun. So the Americans and the
Right.
Russians cut Germany up and they're like, look at all this awesome rocket technology and super gun technology. The super gun was not right for mutually assured destruction. Wrong tool for that.
Right.
That was
Because you can't hide the gun.
correct. You can't hide it.
Yeah.
You can't move it.
Yeah.
So it was the wrong, and also like, it's a big capital expense and then you have low marginal costs, but you're only going to shoot once and then you end all life on the planet. Okay. So rockets make a lot of sense. And it's kind of like if one
Yeah.
out of 100 of your rockets fucking explodes for no good reason, who cares? You have 99 hydrogen bombs in the air, right? So like we put stuff into space with rockets because of a $4 trillion investment made over the course of the Cold War by the Soviet Union and the Americans into rocket technology, not because anybody was interested or making large scale decisions about capital allocation from the perspective of
Yeah.
like, let's have a moon colony someday, but because a lot of people wanted to build weapon systems,
Sure.
strategic weapons.
That was one of the that fundamental reality about the real purposes of rocketry was one of the harder things to really internalize from JPL, the focus being on scientific exploration and improving the world. So I think we maybe want to do a second episode, but I want to get to get to a conclusion here, but I want to get back to the question of the firing distance. So just out of curiosity, what is the first goal for actual flight distance? At which point you'll start testing that and no longer point it at the ground? Or do you not think of it that way?
Kind of a function of the customer. Like if
Okay.
I've got a Air Force customer that wants to do like an application I'd love to do, hypersonic skeet shooting. Vehicle comes out, hits the atmosphere, skips up, and now you've got like a ersatz Kinzhal Russian hypersonic missile flying through the air at like Mach 7, and it's super cheap to do that. Can you shoot down one of those things with a Patriot? Who knows? Maybe it'd be nice to practice, right? And you don't want to pay $25 million for a rocket for each time you do that. Maybe you want to use the big
Right.
potato gun on the ground. So I think that's a good application.
Hmm.
I think that like the first thing that we throw for distance is going to probably be a function of is like somebody at Anthropic interested in like competing for space-based data centers and wants to go hard into Longshot.
Hmm.
And then we're just like, skip all the defense work. We're a space launch company. Or do we have to build up off defense applications before we can go to space?
Sure.
So that's kind of like, it depends
Yeah.
on where the market leads us.
And that I love the answer because despite having made many mistakes in the past where I think, hey, look what we can do instead of, hey, look what the customer wants. I just did it again. I said, hey, I was thinking, what can you do instead of what does the customer want? Before we conclude, spin launch, the spinning acceleration thing, an obvious comparison, but not linear. What do you think about it?
Poisonous allure of novelty, my friend.
Mm.
The goal should be to steal everything you fucking can from history, not to do something new. Solve hard problems with old solutions. And there's just too much novelty in that system. Like the centrifugal force, like people don't build centrifuges that large for a reason. The centrifuge arm would have had to be the strongest object in tension ever built by human beings. You were going to be applying 10,000 to 15,000 G centrifugal pressure to the vehicle, the cigar body of the rocket, right?
Yeah.
They were only talking about, because of these limitations, they were only talking about exiting the accelerator at a small fraction of orbital velocity. So they're really only replacing like half of the first stage of a rocket. So now you have to put a second and third stage on the rocket itself. So like, I will say this, I think that spin launch is a tragedy because they executed well. They went out to the desert. They built a huge thing. It's not trivial to do that. They solved hard problems to get as far as they did, but it was a poison pill. That technology was never going to scale. Never going to scale in space launch.
Sure.
So now I think they basically have pivoted and they make satellites now. I think that's what spin launch is.
Yeah. Well, yeah. Well, speaking of pivoting, back when I first got access to ChatGPT Pro research mode, I said, how big would the giant tilting catapult thing?
Well, trebuchet need to be to throw.
How big would a trebuchet have to be to fling something into the low Earth orbit? And it was like 10 miles tall, and of course would have to be the strongest thing ever made.
Right.
So anyway, yeah. So I think that a great way to conclude is really with this insight of the simplest possible solution. And you've made a great case for it, I think.
Steal everything you can from history. Steal it as much as you can. I think that history is actually kind of littered with technologies that were abandoned. This technology, the thing is, most people who focus on aerospace engineering and on the future of space are technically minded. And so when they look at sort of like, why is the world the way it is, they tend to glom onto technical explanations. We must put stuff into space with rockets because they're the right technical solution. When that is wrong, it is because they were the right, it was a market fit.
Sure.
It was a market fit for a different market. Market costs of access to space today very clearly is the gating factor. It is the thing you must overcome if you want to make a lot of money in space. Like right now, Varda, every other business that does big business in space, that has a plan for $1 trillion business in space. If Varda were to invent the cure for cancer in low Earth orbit next week, and it can only be made in microgravity, and they have a patent for it and everything, how long before Elon Musk tweets, I just had this great idea. And he can just execute on it better than you, and there's no amount of lawsuits that are going to stop him, and he's going to crush your mush, right?
Yeah.
Like everybody who doesn't have their own access to space, who has a big plan for doing business in space, in my opinion, is doing market research for Elon. He has already decided to compete in 4 or 5 different verticals, right? And he's just going to keep doing that. The only reason Planet Labs exists today, the only reason Earth observation is a vertical where you can have competition is because they don't make enough money. They don't make enough money to attract Elon's attention. That's it.
Interesting.
So like, I think that like, this is the problem. This is the problem. If you want to be the next Rockefeller of the fucking solar system, you solve launch.
I think that's a great place to end it. And I think you make a great argument for giant space guns. So
you want to do a second episode? I'm happy to do it. There's lots of more questions.
Oh yeah.
Of course.
Yeah. Let's talk about that. But for now, thank you, Mike, for your time and a very, very spirited and interesting discussion.
I can't not be spirited. It's a condition.
Oh, I hear you. This announcer voice of mine is fake. So on that note, thanks again. And thanks everyone for listening. This has been the Space Madness Podcast. We'll see you next time.
Cheers.